All right, Algebra 2 people, here's section 4.1, part 2, graphing quadratic functions still. But today you may notice something a little bit different. Last time we were working with these, we had numbers in front of x squared, and we had constants in the back that shifted it up and down. But today we have a middle term involving an x. And what that means is that the graph has been shifted left or right. And I can show you what later on we'll get into something called vertex form, and I'll be able to show you exactly where that x comes from and why that means there's a shift. But for right now, take my word for it, that 6x is going to shift your graph left or right. Now, before we get into this, we're going to need to look at something. Standard form follows this format right here. Y equals ax squared plus bx plus c. Where sometimes you have a number other than 1 out front. Sometimes you have a b value, sometimes you don't, sometimes it's 0, I suppose. And sometimes you have a c value. Well, when we write it out this way, a is associated with x squared, b is associated with x, c is a constant. We're going to use that to our advantage here. I'm going to break this down into 4 steps. To graph these graphs that have been shifted, first decide if they open up or down. So by looking at this, you can still look up front, and because there's a negative, that's indicative of a graph that's opening down. So that still holds true. In addition, if I had like a 5 out there, 5x squared, that would be a vertical stretch. If I had a 1/3 out front, that would be a vertical shrink. So those transformations still hold true. Now, next up is we're going to decide where or exactly how much this graph has been shifted one way or the other. And to do that, we're going to use a formula. We're going to calculate our axis of symmetry, that center line, by doing negative b over 2a. And in our example here, our b value is a 6. And our a value, because that negative, is a negative 1. We simplify it a little bit. Multiply, now divide. And we get 3. More specifically, we get x equals 3. And that is our axis of symmetry. So we immediately go to our graph. We go to where x is equal to 3, and we draw a dashed axis of symmetry at x is equal to 3. Now from there, what we can do is we can find the vertex. We know our graph is centered on this axis of symmetry. Well, our vertex is going to be on that axis of symmetry. And we actually have the x value of our vertex. Our vertex is going to start out with a 3. But what we need to find is the corresponding y value. So we go y equals, and then we substitute 3 in for x. Either grab a calculator or do this by hand. Please do the calculations with me. -9, 18, -8. I add those all up. I get y value of, whoops, not -1, but just a 1. So the 3 from what we had for our axis of symmetry combined with the 1 that we just calculated forms our vertex. So I'm going to go up over 3, up 1. So our vertex is at 3, 1. Now we're narrowing in. We know that this graph is going to open down, but we need to know the specifics. We want to make an exact graph. So since we know that parabolas and quadratics, when we graph them, that they're symmetric, I'm going to get half of the graph using a table of values, and then I'm going to reflect it over. And that's what step 4 is. Find 2 points to the left or 2 points to the right of the vertex. Since I'm at 3, I'm going to make it easier on myself and use 2 and 1. That'll be one side. And we plug those values in to find out the corresponding y values. And let's see, that'll be a -4, a 12, so that's going to be 8, and then 8 minus 8 is a 0. This will be a -1, plus a 6 is 5. 5 minus 8 is a -3. So 2, 0 is a coordinate, and 1, -3 is a coordinate. Reflect them across our axis of symmetry, and then connect our dots, and we have our graph. If we had just done a table of values, -2, -1, 0, 1, and 2, all we would have gotten is these values right here, and we wouldn't have been able to tell exactly where our vertex was unless we did more coordinates. Using this technique of using a formula for your axis of symmetry means that we can find the vertex of graphs that have quite large numbers in them, which is a pretty powerful thing that you can do. We're actually going to find out very soon in our next lesson that this formula models a ton of real-world examples, real-world possibilities, and we're going to find out that the vertex has an important meaning. All right, before we move on, what's our domain? Well, it's our x values, and there's no restrictions on those, -infinity to infinity. But our range, since it's going downward, it's -infinity up to 1. All right, so 4 steps. Up or down, axis of symmetry, vertex, 2 more points. Let's try another one. Step 1, does it open up or down? It's positive out front, so it opens up. Step 2, calculate our axis of symmetry, -b over 2a. Multiply, divide, whoops, not a -3, but a -2. I go ahead and go straight to my graph, go to x is -2, draw my axis of symmetry. Now I need to find my vertex. So step 3 is to find our vertex. And this is in function notation. Don't let that bother you. That's just a y. So we go y equals 3/2, -2, 6 times a -2. Calculate those values. That's going to be 4. That'll be a 6, a -12, a 4, and we're looking at -2. So my vertex is at -2, -2. We're getting close. We know this opens up, but we need to find out exactly where it crosses things. So let's do a table of values, and we want to use values that are next to my -2, either 2 to the left or 2 to the right. I think it'll be a little bit easier to do 2 to the right. -1 and 0. Now we do have to calculate those points. Don't get exhausted here. If you want to, you can grab your calculator, make sure these your answers correspond with mine. Oh yeah. I get a -1/2. Those zeros wipe out a whole bunch of stuff, and I get a 4 there. So these are coordinates: -1, -1/2. 0 up 4. Reflect them over. Make our graph here. I think I may hear my family coming in, so it may get a little noisy here in just a second, okay? I apologize. But you know, families, they exist. Domain and range. -infinity to infinity. In our range, my lowest y value is a -2, so I need to make that a bracket. My biggest y value is infinity. Okay, so now for this last step here, or this last example, it's not asking us to graph. It's asking us to tell whether that equation has a minimum or a maximum value, and then they want us to find it. So let me show you what that's about. Over here to the side, let's kind of quarantine a little area to make some notes. If a parabola opens up, it's like a valley, and it has a minimum. It has a minimum value. You can't ever get to the maximum value, but it has a minimum value. If a parabola opens down, it's like a mountain, and it has a maximum value. Sounds like my son's in pain there. Hold on just a second. Oh, are you okay?
I'm coming in.
I know.
When I was holding the door shut.
I know, that's happened to me a bunch. Yeah, I'm recording a lesson. Are you okay though? It hurts. That happens to me. That's happened to me a bunch of times. All right, now what you may notice is that those minimum and maximum values are actually found at the vertex. So on this example, where it says to tell whether it has a minimum or maximum value and then find it, we're going to have to determine first off if it opens up or down, because that negative, it opens down, which means it's going to have a maximum value. And then to find it, we have to do our first two steps. Or I'm sorry, our first three steps. We already found out it opens down. Next up is we need to do our axis of symmetry, -b over 2a. End up with just a 1 value. And then we take that 1, substitute it back into the equation to find the corresponding y value. And I'm getting a corresponding y value of 5. Now, to be clear, the maximum value is 5. That is the value that they're looking for. But I would understand it if you'd go ahead and give your answer as 1, 5 as a vertex. Either one I would consider correct. And there you have it. Well, the practice for this, I already gave it yesterday. But page 240, or in the last video I should say, it's page 240, numbers 1, 7 through 39, every other odd. And there you have it. Thanks so much for watching.